you for joining me. Welcome to TJ's Maths Clinic. Let's consider this question. We are asked to evaluate the limit as x tends to minus 1 of 1 minus root x upon x squared minus 1. This is under differential calculus, limit of a function. Let's look at how we can handle this. Let's write down the solution. We have the limits as x approaches 1 of 1 minus root x divided by x squared minus 1. Difference of 2 squared. We have difference of 2 squared in denominator. We can write this as the limit as x approaches 1 of 1 minus root x divided by x plus 1, then x minus 1. Very important. Next thing to do is to find the conjugate of what we have in the numerator and rationalize. The conjugate of 1 minus root x is 1 plus root x. So we use that to multiply our numerator as well as our denominator. So 1 times 1, that's 1, plus 1 times root x, that's root x, minus root x times 1 is root x, minus root x times plus root x, that will be minus x, because root 3 times root 3 is equals to 3, or root a times root a under the rules of sort is a. Very important. This will now divide 1 plus root x. We introduce a square bracket of x plus 1, then x minus 1. The limit now as x approaches 1. In our numerator, plus root x minus root x will be 0. So we are left with, let's move here. We are left with the limits as x approaches 1 of 1 minus x divided by 1 plus root x of x plus 1, then x minus 1. Clearly, we can remove this. But before we do that, we have to adjust what we have in the numerator. So let me remove this and move here. In our numerator, we have the limit as x approaches 1 of 1 minus x divided by 1 plus root x, then we have the square bracket of x plus 1, then x minus 1. We can adjust 1 minus x as 1 minus x is the same thing as minus x minus 1. Very important. Minus times x, we have minus x. Minus times minus is plus 1, we have plus 1. So in other words, in place of 1 minus x, we replace it as minus open bracket x minus 1. The reason is so that we can remove what you realize that we will have x minus 1 in the numerator, x minus 1 in the denominator, so that we can cancel out. So the limit now, as x tends to 1, in place of 1 minus x, now we replace minus x minus 1 divided by 1 plus root x, then we have the square bracket x plus 1, then x minus 1. And this, we remove this. We are left with the limit now as x approaches 1 of minus 1 divided by 1 plus root x into x plus 1. Can we take the limit now? Yes. The reason why we can't take the limit here, if we plug 1 directly into this, 1 square is 1 minus 1 is 0. The limit will not exist. It does not exist. Division by 0 is not allowed. That is why we can't plug 1 direct into this function. So we have to use this method or use this procedure to simplify first. Okay? So substituting 1 or plugging 1 into this function directly, the function will not exist. Okay, so finally now we can take the limit. The limit now as x approaches 1 now will be, we have minus 1 divided by, anywhere we see x here we put 1. It will be plus root 1, then 1 plus 1. This will now be minus 1 divided by, square root of 1 is 1, 1 plus 1 is 2, then multiply by 2. That will be minus 1 divided by 2 times 2 is 4. So the solution will be minus 1 divided by 4. As I said, plugging or substituting x or 1 for x into this function, the function will not exist, does not exist, because division by 0 is not allowed or is undefined. So that is why we have to find the conjugate and rationalize. That's the first thing to do. So this is the solution to this question. Thank you for watching. Please do share this to your learned colleagues. And don't forget to subscribe to TJ's Maths Clinic for more interesting videos. See you in my next video. You can follow me on TikTok, Instagram, and Facebook. Thank you for coming.